Hi Pre-Med 101 people. This is Mike Moore from Prep 101, and I'll be walking you through a brief tutorial on this simple equation that costs so many people marks. The pKw equals pKa plus pKb. We have a sample question here. Phosphoric acid and its conjugates have the following dissociation constants, and they are listed here. We're asked what the pKb of H2PO4- is. Take a moment, pause the video, and give this a go. All right, I'm going to give you the punchline here first. If you came out with pKb is equal to 6.80, that is incorrect, and this video is just for you. If you came out with a different answer, well, you've probably got this, and you're probably not going to get any more from this video. So let's go through how we should actually think about this. What we need to realize is that in this equation, the pKa and pKb are conjugate acid-base pairs. This is something that's very easy to hear and think that one understands, even without understanding it. On the previous example, if you used the pKa for H2PO4-, then you didn't find the conjugate acid or base of H2PO4-. You picked the exact same thing. This can be a little bit hard to imagine, so there's a particular phrase that I recommend thinking about. That's, what is the conjugate of the species I was asked about? Let's go back to the question and answer the question after thinking about that phrase. They're asking for the pKb of H2PO4-. That's telling us that H2PO4- here is acting as a base. So if something's acting as a base, we are looking for the conjugate acid. Our first question then should be, what is the conjugate acid of H2PO4-? Okay, well, that would be gaining a proton, so that would be H3PO4. Don't need the negative sign anymore. So that would be H3PO4 with a pKa of 2.14. Then we can finish this question. We're going to use the equation that this tutorial is named after. No surprises there. But now we're going to be using different pKa's and pKb's. Our pKw, no surprise, is that 14. That's a number that you are going to want to have memorized for your MCAT. The pKa is the new thing here. The pKa is that 2.14. We're adding the pKb. And when we solve that, we're going to come out with a pKb of 11.86. So 11.86 for the pKb of H2PO4-. We have a similar question here. To solidify your knowledge, pause the video, give it a go. Good luck. All right, I hope that went well for you. Let's take a look. The question tells us, arginine and its conjugates have the following dissociation constants. And then it gives us all that information, and eventually we're asked for the pKb of this species. I'm going to identify this species as the last one here. But remember, the first thing I need to do when I'm asked this kind of question is find the conjugate. They're asking us about a pKb, which means we're looking for its conjugate acid. So we're going to find its conjugate acid. Its conjugate acid is going to be this middle one with a pKa of 9.04. So we can now find our lovely pKb using the equation that we've seen a bunch of times before now. And when we do that, we're going to come out with a pKb of 4.96. 4.96 is the pKb of this species. All right, one more, and we're flipping it around for you now. Pause the video, you know the drill. Good luck. All right, we're looking for the pKa. Oh, that's different. The pKa of this citrate ion. All right, fair enough. So this is acting as an acid. We need to find its conjugate base. Its conjugate base. So what is going to be the conjugate base? Well, that will be when this thing has lost a proton. So if it's lost a proton, we're going to go from 6 to 5. And this first one is going to be the relevant pKb. You're hopefully sick of seeing this equation by now, but that's kind of the goal. If you can be somewhat bored while writing your MCAT, amazing. We're going to sub in the numbers. The pKb this time is that 3.13. We're looking for the pKa. So our pKa is going to come to 10.87. All right, fantastic. I hope you've enjoyed this tutorial. How to use that pKw equals pKa plus pKb is something that so many people mess up. But once you know to look for the conjugate, you're going to have a good time. Thanks for watching, and good luck on your MCAT.